All right, section 3 is going to be where we actually get into figuring out some probability here. So we have to start with some terms and define a few things, and then we'll get into actually figuring out some probability in certain situations. So first we want to define theoretical probability, and we'll need to distinguish that from what is called empirical probability. So here's our definition of theoretical probability. Theoretical probability is the ratio of the number of elements in an event to the number of equally likely elements in the sample space. Okay, so an event is a particular outcome or set of outcomes that we're looking for, and the sample space is all of the possible outcomes. So what we're saying here is the ratio of the number of elements in the event. So the number of possible ways that we can get what we're looking for divided by the total possible outcomes. So if we're saying we want to draw an ace from a deck of cards, well, there are 4 different ways that we could get an ace. Getting an ace is the event. There's 4 different ways to do that, and there are 52 different cards in the deck, so there are 52 possible outcomes. The probability of drawing an ace would be 4 over, right? There's 4 aces in the deck out of 52 cards, and you can reduce that. You could say 1 out of 13. But that's the concept of really all the probabilities that we're going to look at, and that's always the way that probability is figured out, is the number of ways that you could successfully see the event you're looking for divided by the total number of ways that this experiment or trial could go, total possible outcomes. Some important notation, I used some already. To describe a probability, we'll use a capital P, and then in parentheses describe the event that we're looking for. So in this case, the event was drawing an ace. The probability of drawing an ace is denoted P with ace in parentheses. N of E is the number of events in event E, the number of possible successes. So in this case, for an ace, we could say that N of an ace, the number of possible outcomes that are aces, is 4, and N of S is the number of possible outcomes in the sample space, would have been 52 in our case with the ace. And in general, the probability of any event is always the number of ways that event can happen divided by the number of ways that the trial could go, total possible outcomes. Successes over outcomes. This is really what should be in your mind when you think about how to figure out probability. How many ways can I succeed? How many ways could it go? Some important baseline rules for probability. The probability of an event is equal to 0 when it cannot happen. When there are 0 possible ways to achieve the event, we say that it has a probability of 0. So we would say that this is probability of E equals 0 when the event is impossible. Okay, that's what a probability of 0 means. Truly impossible. Not far-fetched, not incredibly unlikely, but actually impossible. For example, the probability that I get struck by lightning. It is very, very, very unlikely that I'll ever be struck by lightning in my life, but it is not 0. I could get struck by lightning. It is a non-zero probability. But the probability that I ever run a mile in under 1 minute, well, I suppose that maybe future technologies could help that, but that's not going to happen, right? So that would be a probability of 0. Or the probability that I, travel in time. Maybe somebody wants to argue with that, but I'm trying to think of things that are impossible and somehow struggling. Anyhow, so impossible events have a probability of 0. Things that can happen never have a probability of 0. If it's at all possible, the probability is not 0. P of the probability of an event is 1 when the event is guaranteed. Okay, where it absolutely must happen and there's no other possible alternative. So for example, if I were to draw a card from a deck of cards, the probability that I get either a card that is hearts, clubs, diamonds, or spades is guaranteed. I have to get one of those 4. But the probability that I get a triangle suited card is 0. There are no triangle suited cards in a standard deck of cards. Okay, so 0 means impossible, 1 means guaranteed. The probability of an event happening plus the probability of it not happening has to add up to 1. No matter what the event, the probability that it happens plus the probability that it does not happen would be equal to 1 guaranteed. So with the ace, the probability to draw an ace is 1 in 13. The probability they don't draw an ace means I draw either a 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, or king. There's 12 possibilities in the 13 total. So the probability of not drawing an ace, the probability, and we use a little, this guy here to represent not. The probability of not drawing an ace is 12 out of 13. And 1 out of 13 plus 12 out of 13 adds up together to equal 1. Okay, and so those are all related to theoretical probability, but all these ideas about these rules of probability also apply to empirical probability. So let's talk about that as real quick. Empirical probability, also called experimental probability, is our best estimate of the probability of an event based on a large number of trials. Okay, so that would be if we don't know what the likelihood of a certain event is, if we try it 100 times and we succeed 53 times, we would say the experimental probability or the empirical probability is 53% or 0.53 based on our observations. The word empirical literally just means based on observation. So that's what we mean when we talk about empirical probability, is if we run trials and see how many results we get, that can help us determine the probability. This could be like Steph Curry is a great basketball player, right? He shoots his free throws. He's one of the greatest free throw shooters of all time. In his career, he has made 912 free throws out of 1,000 attempts, something like that. So that 912 over 1,000, that is based on our observations of him shooting the ball. So that would be an empirical probability. We could say the empirical probability that Steph Curry makes a free throw is 0.912 or 91%-ish, right? And so when they say somebody is a 92% shooter, that's what they're saying, is the empirical probability that he makes his next shot is 92%. That's what we mean by empirical probability, probabilities that are based on what we've observed. Okay. In the next video, we'll start getting into actually constructing and computing some probabilities.